Hello everyone, welcome back to my YouTube channel Code with Nabil, and today I've brought a very exciting problem. This is a relatively easy problem, but I think this is a good start if you have taken a long break from your competitive programming. So the problem is called the product sum. So let's dive into the conceptual overview of this problem. So basically in this problem what we have is we have an array. It is called a special kind of array because as you can see here that what we have here like this is for instance, let's say we have an array, or you can call it a list in Python. If there is only single list, we call this a depth 1. Okay, we call this of depth 1. And if we have a nested list, which is a list within a list, so in this case the depth will be 2, right? And similarly it goes, as we increase the depth also increase. So the problem here says depth of this single list is 1 and the depth of the inner array is 2, like this one. And similarly, as you go to the innermost, in this case the innermost depth is 3. We also have one example here. So let's say the product sum of x comma y will be simple as x plus y because it is in the first depth, and the product sum of x comma an inner list of y plus z will be x plus 2 into y plus z. Pretty straightforward, right? So if we try to understand how we can solve this problem, it's very simple way. What we need to do is we need to first we need to keep track of wherever we are finding the innermost list. So what we can do is we can do it in a recursive way. As soon as we finding the list, we can keep a counter maybe or something like that, and then we can keep on incrementing it once we find an inner list, and we can multiply it recursively and then return the sum to the outermost. So that's basically going to be our approach for the sum. So if we look at the sample input here, the sample input is pretty straightforward here. So over here, since this is in the first depth, so 5 plus 2, and then what we do is as soon as we encounter this first inner list, now this is the first inner list, so we multiply this with 2, the summation of these two numbers. So 7 plus minus 1, which is 6, multiplied by 2, and then plus 3, since 3 is in the outer list, not in the inner list, so it will be multiplied by 1 only, so plus 3 like it is. And then again we are going to second level, plus 2 into 6, and over here we are going into the third level as well. So what we'll be doing here as well, that we will be multiplying this the third most inner array multiplied by 3, and then the result of this will be multiplied by 2. And finally this 4 is outside of the, let me clear this up, this 4, let me use the eraser here. So if you see, look at this 4 here. Yeah, this 4 is in the second most depth and not the third most. So this is multiplied by 2 only. So yeah, that's what the approach we're going to follow here. I think it is better that we follow go to the implementation detail directly because it's a relatively very easy problem. So let's jump directly into that. So over here we have a product sum function defined. What we do is, let's say we define one parameter array and we have a multiplier parameter. Let's provide this as a default argument, multiplier equals to 1. And what we are going to do here, we are going to keep a number total sum, maybe we can initialize it to 0, and then we are going to iterate over the entire array we have here, right? So we can do simple as this for element in array. And in Python, since we're using in Python, the Python unique way of doing it is we can check whether we have encountered an inner list or not. And we're going to do this simply by just checking like this: if element equals to, we need to check the type of it, right? So if type of element equals to list is a Pythonic way of doing, maybe in Java or C# or another language this might be a different way, but essentially you have to find the inner list, right? So we are doing this right here. So if you do that, what we can do is we can just do a summation of, and we can call this our subproduct sum recursively with the nested list, which is our element, and we can increase the multiplier by 1. So we are going, so what happen, I'll just give you a dry run as well once we are done with the implementation. Else, if we are not encountering the list, that means we are in the the original depth, what we can do simply is total sum plus equals to element. And finally, once we are out of the loop, we have to multiply total sum with the multiply, whatever that is, right? So the implementation is very simple and straightforward, but I would like to give you a run through of an example. So let's say we have 1, 2, and we have an inner list of 3, 4. So what will happen here is, let's say in the first iteration, we will have total sum over here, right? We'll have the entire array passed to this function, and with the multiplier is equals to 1. So it will check the first element. Is this first element a list? No, it's not a list. So this will come here. So we'll have total sum here as 1, and then it will go into second iteration. Second element, is second element a list? No, it is not. So total sum will be appended with total sum will be incremented, and this will be now 3. And in the third iteration, as soon as we find a list, this time what will happen is it will call the function, this function product sum recursively. It will call the product sum recursively because this condition is now will be true. Now this will, as soon as it encounters the inner list, this condition becomes true, and this comes here and it calls this product sum recursively by this parameter, by this inner list 3, 4, and the multiplier also increases by 2. So this is the multiplier, this is the multiplier, this is the innermost list. So this will run recursively in a similar fashion, and what it will do is again run this function again. It will check if the inner list type is list or not. It is not. So over here we will have total sum of 3 over here, and it will multiply it by 2. So 3 into 2 is 6. It will go again upwards. It will go to the second element here. The 4 into 2, it will be 8. 8 plus 6 will be 14, and 14 will be returned over here. So once the result of the recursive call will be 14 here. Okay, and finally this will be added to the total summation we are doing up here. So this will be total will be 17, and once you multiply this by 1, so the result will be 17. So the answer should be 17 of this. We can also verify this by just running this simple this here. We'll just call this function and we'll see the output is 17. This verifies our result as well. Now let's come to the space and time complexity of this function. You can see here we are using one for loop and we're iterating over the entire array. So as simple as that, the complexity, time complexity will be of n, where n is total number of elements in the original array, which also include a sublist. The space complexity, however, will be the O of D, where D equals to depth of subarray, where D equals to depth of subarray. So yeah, that's it, folks. I think you like. I hope you like this problem, and if you want to have more of these kind of problems and maybe some web development project as well, you can follow me, subscribe me, and provide me with what you want next. Thank you so much for staying around, and till then, see you in the next video. Bye bye.